Okay, let's finish up Boglog Theorem and look at roots of complex numbers. So we're going to start out today trying to find the fifth roots of negative 32. So let's just call those fifth roots x. So we want to find the fifth root of negative 32. And I know some of you are seeing negative 2 as an answer. Yes, it is, but just please bear with me because there's a couple other things that I want to show you here. So let's just raise both sides to the fifth power. So we'll have x to the fifth equals a negative 32, which means then that x to the fifth plus 32 is equal to 0. And we go on back to pre-calculus earlier this year. I'm sorry, I'm so used to saying that for my calculus class. To look back, oh yeah, I remember pre-calculus and for a moment there I forgot that I was still in pre-calculus class here. So, all right, let's try to factor this. Now, a couple of things going on. You remember the graph of this, x to the fifth plus 32 is going to take an x to the fifth graph and shift it up to 32. So we're looking at something like that, where that point right there is 0, 32. Okay? When we try to find this 0, yes, I know some of you already know that that point is negative 2, 0, but let's just go back through and remember some things from earlier this year. We could do a synthetic division with that negative 2 to see if there are any other zeros that we might find. So let's see, x to the fifth, x to the fourth, 0x cubed, 0x squared, 0x, and then a 32. Remember the synthetic division? We break down 1, and then we multiply. 1 times negative 2 is negative 2, and this is negative 2, multiply, 4, and multiply, and multiply, and multiply, remainder 0. That makes sense. If that's a 0, then we should get a remainder of 0. All right, so we could try and factor the rest of this. Remember, this is now in degree 4. X to the fourth minus 2x cubed plus a 4x squared minus an 8x plus a 16. We could try another negative 2 and see if that works. Maybe this is, we have 3 negative 2s sitting here. We have that triple root kind of going on. So let's try this depressed polynomial, 1, negative 2, 4, negative 8, and 16. And we're going to see if that negative 2 goes in there again. See 1, we're going to multiply, that's negative 2, and multiply here, negative 2 times negative 4 is 8, and that would be 12 times the negative 2 is negative 24. When we add that, that's a negative 32. Negative 32 times negative 2 is 64. When we add those, that's 80. That's a remainder. That means that negative 2 does not divide into this polynomial anymore. So we are kind of stuck. But we do remember some other things, and that is that there was one real root right here. One real 0. Remember, root is something, another word that we can use for 0. So we have one real root, and there are 4 complex roots. Remember that? We had to have a total of 5 roots. All right, kind of stuck at this point. So we need to use something called Boglog Theorem for roots of complex numbers in polar form. And his theorem says if z is equal to r cis theta, then the nth root of z, which is z to the 1 over n. Then what we're going to do is we're going to take the nth root of r, cis, theta over n plus 360k over n for k an element of 1, 2, 3, 4, etc., all the way on down to n minus 1. This is his formula or his theorem for finding the nth roots of a complex number in polar form. Yes, you have to memorize this. Yes, you need to memorize that. All right, let's go back to this problem we were working on from the previous page, and let's see if we can apply this theorem to that. So, we were wanting to find the fifth roots of negative 32. So, that means that we want to find fifth roots of negative 32. Now let's write it as a complex number so that we see that imaginary part, negative 32 plus 0i. And we're going to need to rewrite that into polar form. So convert to polar form. There are two ways to do that, and you can choose either way. One way is to look at a picture, and negative 32 plus 0i is over here, negative 32, so plus 0i, so 32 out this way, and 0 going up. That distance, 32. When we convert this to polar, then we look at this angle, and that angle is 180 degrees. And we see that the length of this vector is the r value, it is 32. So when we convert negative 32 plus 0i into polar form, we get 32 cis 180 degrees. If that bothers you, the drawing the picture thing, the other option is to go through and find r as the square root of a squared plus b squared, which would be the square root of 32 squared plus 0 squared, which is just 32. Theta, oops, it was negative 32. And theta is inverse tangent of b over a, which would be 0 over negative 32. A is less than 0, so we will have to add 180 degrees. The inverse tangent of 0 inverse tangent of 0 is 0 plus 180. Theta is 180 degrees. So whether you like the picture or whether you like to use the formulas, either way, you need to be able to come up with this complex number in polar form. All right, now let's go ahead and do those roots. And following this formula right up here, oops, let me move this down so you can see it. So finding the nth root of z, so we want the fifth root of this number, means we're going to have to do the fifth root of the r, fifth root of 32, cis, theta over n, here's your theta, 180 divided by n, that's the number of the root, so divided by 5, plus 360, k divided by 5. When we simplify here, we will get the fifth root of 32 is 2, cis, 180 divided by 5 is 36, plus 360 divided by 5, 72K. Once we have this general setup, now we start substituting in some numbers for K. If K is 0, then our root is 2 cis 36 degrees. If K is 1, then we have 2 cis 36 plus 72. 36 plus 72, 108. If K is 3, then we'll have 2 cis 36 plus 72 times 2, 36 plus 144. Or just adding on another 72 onto this one, that's 180. If K is 4, here's 2 cis. We're just adding on another 72, so that would be 252. If K is 5, we have 2 cis. Oh, did I miss one? Oh, look at what I did, stupid. Me, not you. K is 1, K is 2. Some of you are having a heart attack that I made that mistake and you can't fix it, or you couldn't tell me, but I figured it out. Okay, so this should have been K is 2. I think I said 2 times 72, 144, but I wrote 3 here. This one should have been K is 3. So 36 plus 72 times 3. Or you can just notice that you're adding on another 72 each time. If K is 4, then we have 2 cis, add on another 72 here, gives us 324. If K is 5, we get 2 cis, all right, add on 72 gives us 396. All right, a couple of things. Some of you are, I know you're jumping out of your skin trying to tell me, but I'm not there, really. So you couldn't tell me that I shouldn't have checked K equals 5 because we're supposed to keep going until K is n minus 1, 1 less than the root. So I should have stopped right there at 4. The other thing is if you forget that and you keep going, right there at 396, subtract the 360 to get back within 1 time around, and you're right back up here at this first one. So this one we never should have even calculated. That's it. Here are your 5, oops, I should have put that there. There's your 5 fifth roots of negative 32. And we knew there would be 5 of them. Okay, now, wait, our original problem was in rectangular form, so we need to convert these back to rectangular form. Oh boy, let's just do this first one, or just not this first one, this one right here. Let's just convert that one back. Can you think about what that's going to look like? 2 cis 180. 2 cis 180. 2 this way at 180 degrees. And when we look at this in terms of A and B coordinates, this would be A is negative 2 and B would be 0. So this would be negative 2 plus 0i. Wouldn't that be the same thing as we got right away on the other page? That the root was negative 2? Absolutely. These guys are not nice values, so you would have to go back to your calculator and convert these guys all into rectangular form. I'm going to let you handle that on your own. Hopefully you are able to convert those back into rectangular form. I did want to show you this one. But you should see that in all of these, at 36 degrees, 108 degrees, 252, and 324, there will be a real part and an imaginary part. And, oh man, I bet 2 of those are going to be conjugates, and the other 2 are going to be conjugates of each other. Remember those complex roots came as conjugate pairs? Yes. All right, lots of stuff coming back to you today. Let's take a look at this very last problem then. I would like you to find the complex cube roots of -8 minus 8i. All right, right here, we're finding complex cube roots. How many answers are there going to be? Yep, there's 3 because we're doing cube roots, so there's going to be 3 of them. And if we start plugging in through, we want to find the cube roots of -8 minus 8i. And we need to convert that to polar form. Let me move this out of the glare of the sun here. So, cube roots of, okay, I recognize that this is probably going to be a 45, 45, 90 because of that 8 and 8. So I'm going to sketch this graph. -8 minus 8. Right here. That distance is 8. That distance is 8. So the radius here, or the length of this vector, is 8 square root 2. We have a 45, 45, 90. And then cis, the angle here, is 180 plus 45, or 225. All right, finding that cube root now of that polar number, or complex number in polar form, we'll need to do the cube root of 8 square root 2. Cube root of 8 square root 2, cis. Then this is theta divided by n, so 225 divided by n, which is the root number, so 3, plus 360k divided by n, which is 3. Oh boy, we need to deal with this cube root of 8 square root 2. So I'm going to come down here and deal with this off to the side. That would be cube root 8 times the cube root of the square root of 2. Cube root of 8, 2 times, now let's look at this. This is going to be square root of 2, so I can write that as 2 to the half, and then cube root to the third, which is 2 to the 1/6, which would be 2 6 root 2. So I'm going to pop that back up here. 2 6 root 2 cis. All right, 225 divided by 3 is 75, plus 360 divided by 3, 120k. And now to find those cube roots, we set up k equals 0, k equals 1, k equals 2, and we're going to stop right there at 1 less than the root. If k is 0, we have 2, 6 root 2, cis, 75, k is 1, cis, 75 plus 120, so that's 195, and then 2, 6 root 2, cis, we're just adding on another 120, so add on a 120 onto here, 315. There are your 3 cube roots of -8 minus 8i. There's your 3 cube roots. All right, I'm going to tell you to leave your answer in polar form, but be able to convert to rectangular form if I ask you to in the test. Okay, that finishes up chapter 9. So please make sure you are working on your homework. I will see you on Friday. Bye.